Hello everyone, let us now discuss how can we solve this problem. Partition labels. So we are given with a string in which we need to do partition the string into so many as many parts as possible so that each letter appears at most one part. That means if it is having ABABCC, so B is present only in one partition or one part. A is also present in only one part. C is present only in one part. It shouldn't be something like B is in one part, one B is in one part and another B is here. Like so here we are given with two A's and one B. So there should no part which contains A and also B. But here BCC contains another B, and also here AB and here AB and also here CC. So if I take a part of AB, that means AB should not be repeated again in any part. So note that the partition is done so that after concatenating all the parts in order, the resultant string should be S. Now, let us understand this by taking this example. Here I have A, A, and if I take a partition here itself, like let me say whether can I take a partition here or not. If I take a partition here itself, then I am missing one A here, right? So I don't take a partition here. What if I take it here? Now I have a B and also A, and there is another B here. So think something like this. So checking whether there is another character in the string after the partition. So before the partition, I am taking some elements. So consider that alphabets that are repeating or not after the partition. So if repeated, it is not a valid partition, right? Now let us see what happens here. Here B, if I take AB and take a partition here, but A and also B is repeated again, so this is not a valid partition. So let me take another A. Here if I take a partition, I have another A here, so it is not a valid partition. Now if I take B, whole B, here B is also repeated, A is also repeated. Now let us see whether can I take a partition here, C. Now if I take this partition, but C is also there after this. Now if I take this B, is it present a B? No. C is also not present, but A is present, so this is not valid partition. Now if I take another one, A is also present after that. Now if I take this partition, A is already present here. Now if I take this partition, I have A, I have B, I have C till here. But let me check whether do I have any A here? No. Any B here? No. Any C after this partition? No. So this is a valid partition. So this is a valid partition. Now let us see how can I go through the next partition. So till now I got A, B and C. Now here I am taking D, right? So if I take a partition here, another D is present here. No, I can't take the partition. Here, if I take this E, there is another E here. So I can't take this partition. If I take this, E is present again. So I can't take it. Here, no, because E is present again. Here, no, because E is present again. Here, no, because E is present again here. Now, here, right? I got in this partition, just this partition. Now, even if I take all this from here to here, this ABC are not going to repeat in the next substring, but I need to check whether these are repeated. So I have A, B, D, I have E, I have F, I have G. Check whether these four characters or alphabets are present in this substring. So if I check D, it is not present. It is uh, E is also not present. F is also not present. G is also not present. So in this way, I can take this partition as a correct partition. Now let me check whether can I take a partition in the next alphabet. Here H. So I am checking only this. Only this. If I check that this H is present here also. So this is not a valid partition. Now let me take this partition. Can I take it? No, because H is already present after this. Now J. Can I take this partition? J is present again, so I can't take it. H, I, J. I, J are also present, so I can't take this partition. Here, H, I, J, K. I, J are present again, so I can't take this partition. H, I, J, I, J are also present here after the partition, so I can't take it. Here, J is also present, so I can't take it. And here, there is no another substring after that, so I would return the size of this and then this and also this. Now instead of going forward, I am taking this in a backward in the code. You can also go forward and check for the characters. Now what is the algorithm? So algorithm, check whether this is a valid partition. Now for I is equal to 0 to n, check whether this is a valid partition. When I say this is a valid partition, I need to consider all the characters from here to here for this partition to be checked. Let us see. From here to here, I need to check all the characters from here to here and all the characters from here to here. So A is present, B is present, and C is also present. But at this moment of time, at here, if I check whether is it a valid or not, I can't find A, B, C after that. So for that, I no need to check whether A, B, C are present here or not. I simply check A is present for how many times? 1, 2, 3, 4 times. Yes, 4 times. B is present for how many times? 3 times, right? And C is present for 2 times, right? So this is for the current partition till here, and it is also for the whole string. If you doubt, check again that A contains for only 4 times, B contains for 3 times, and C contains for 2 times. So in this way, this partition is valid. Check whether this is a valid partition or not. Now here I is equal to 0 to n. Here let me take two. You can take hash map or vector int for storing the frequency of every character. I am taking unordered map character comma int and naming mp for whole string and also temp for the temporary uh, what do you say, partition, right? So temp of s of I plus plus. Check whether this is a valid partition by taking mp and temp, right? Now I have one thing again to do. After I initialize this mp, take the frequency of alphabets in mp. Now check whether this is a valid partition. I would write this partition valid function something like valid of temp and mp. So I would iterate through if something mp sorry temp of character is not is equal to mp of character. So temp of character is not equal to mp of character by taking auto c comma value. So temp of c, or you can directly write it something like value or frequency. Let me write it as frequency. Here also frequency. If it is not equal, then return false there itself and return true at the end. Now this is for the valid algorithm. Check whether this is a valid partition or not. So if it is a valid partition, then I would take I plus 1 should be pushed back. So answer dot push back I plus 1 into answer array. But before that, I need to initialize vector int answer. So at the last, I would return answer. But in the code, I have written in the reverse order. That means coming from the end and taking these partitions. So this is how you solve this problem. I would give the forward and also the backward approach in the link in the description. So if you like this video, do share it to your friends and do subscribe to my channel.